Okay, let's talk about graphing using intercepts. One of the easiest things you can do is plot the intercepts of a graph. It's very simple. If you want to find where the graph crosses the y-axis, which is the y-intercept, let x be 0 and solve for y. And then if you want to find where the graph crosses the x-axis, which is the x-intercept, then just let y equal 0 and solve for x. Okay. Now this is very helpful on a lot of linear graphs because you know you only really need 2 points to plot a line. So if you can find two distinct x and y intercepts, then you can just draw the line through those 2 points. So here I'm going to get the y-intercept first. I'm going to let x be 0, and when I do that, the 2x disappears and I get 3y equals negative 12. Then I'm going to divide by 3 and I get y equal negative 4. So the y-intercept is 0, negative 4. And then to get the x-intercept, I'm going to let y be 0. And if y is 0, that's just going to give me 2x equals negative 12. And then when I divide by 2, I get x equals negative 6, 0. So again, I take my graph paper, get you some graph paper. Oops, we're cheating. Alright, get some graph paper, find the point negative 6, 0, plot that point, and then find the point 0, negative 4, and plot that point, and then just draw the line that goes through those 2 points. And when you're done, you'll have this right here, and you'll see that that line goes through those 2 points. So very simple to graph a line using x and y intercepts. Now of course, if the line goes through the origin, you're only going to get one distinct intercept. So in that case, then you would have to find another point on the line. Okay, now this is actually a quadratic equation here, and the graph of a quadratic equation in 2 variables is going to be a parabola. Now the parabola that we're going to draw, it has to go through the x and y intercepts. So if x is 0, let's see what y would be. So that would mean we would wipe these out, because if x is 0, those would be 0, so y would be 10. Now, so 0, 10 is the y-intercept. Now if we let y equal 0, right here, like that, we get 0 equals all of this, but let's just turn it around and say it the other way around. Let's say all of that equals 0. Well, this factors. Fortunately, it does factor. If it doesn't factor, you have to use the quadratic formula to find the roots. But it factors into x minus 5, x minus 2. And if you solve those, remember you can solve this by setting these two factors equal to 0. And if you do that, x minus 5 equal to 0, so x would equal 5, and x minus 2 equals 0 means x equal 2. So you know that if y equals 0, then x must be 5 and x must be 2. So you actually get 2 x-intercepts. Okay, and let's take a look at what that graph would look like. You probably need a little more information to get a good graph of it, but if we take a look at this graph, you can see there's the intercept 2, 0, there's the intercept 5, 0 on the x-axis, and then up here you have the intercept 0, 10 on the y-axis. We'll talk more about graphing these types of parabolas in a later lecture. Okay, now the last one that I want to talk about is actually a rational equation, x minus 3 over x plus 2. So if you were to let x be 0 here, then you would basically, these two terms would disappear, and you get minus 3 over 2, which is minus 3 halves. And so your y-intercept would be the point 0, negative 3 halves. Now, if you were to take that back, and let's say we let y equal 0, then basically you're wanting to know when will this fraction equal 0. Well, the only way a fraction can be 0 is if the numerator is 0. So you have to ask, when does x minus 3 equal 0? And I'm doing that here. But up here I have to say, when does x minus 3 equal 0? And in order to answer that question, you just solve this little equation, when is x minus 3 equal to 0? And that's when x equals 3. There is one catch there. if 3 made the bottom and the top be 0, then of course it wouldn't be an x-intercept. You actually get a hole in the graph there, but we don't have that case here. 3 does not make the bottom equal 0, it just makes the top 0. So 3, 0 would be the x-intercept. And let's take a look at that picture. That picture looks like this. And remember, we had the x-intercept of 3, 0, and we had a y-intercept of 0, negative 3 halves, which is what negative 1 1/2 is. It's negative 3 halves. So that's the two intercepts there. Now, again, you need more information than that to actually graph this, but you can certainly find the x and y intercepts from these functions. Now, you may not have any intercepts. There's no law that says a graph has to go through the x or y axis. So let's take a look at this equation, xy equals 1. If you were to say let x be 0, then you would get 0 times y equals 1, or 0 equals 1. Same thing if y is 0, you get 0 equals 1. And so what you get there is an impossible equation to solve, so therefore you're not going to be able to get either the x-intercept or a y-intercept there. So if you want to know what's going on there, let's just go through here and see what happens with the graph. Okay, so here you'll see that if you go here, if you keep going and going and going, then you're going to get infinitely close to the x-axis, but you're never going to touch it. And then up here, the same thing with the y-axis. You're never going to touch it or cross it. And the same thing over here. So, you know, you're not going to touch it. These are actually situations where you have what's called a vertical and a horizontal asymptote, which we talk about in a later lecture. But this one has xy equal 1 is a graph that has no x or y intercept. All right, let's now talk about graphing circles. To graph a circle, it's easiest to graph if it's in the standard form, where you have like x minus a constant squared plus y minus a constant squared equal the radius squared. When it's in that form, the center of the circle is at the point hk, and the radius is r, just the square root of whatever this number is. So if you were to be given this circle, well, you can think of that as x minus 0 squared. That x squared is the same as saying x minus 0 squared. So here you could say the h is 0. And then here we have y minus what squared. Remember, it's got to be what are you subtracting. We're subtracting a positive 2. So k must be 2. So the center must be at 0, 2. And the radius must be the square root of 9, which is 3. And so let's take a look at that on the graph. Now here's the center. This is the point 0, 2. And you could actually get, what's it called, compass, protractor, I forget. But you could draw the circle. But actually, if you know this is the center, and you know that the radius is 3, then you could just go, what I call it, the 4 directions. You can go 3 to the east, that'd be west, wouldn't it? No, 3 to the east, 3 to the west, 3 to the north, 3 to the south. And so you could label 4 points, one here, one here, one here, one here, and then you could do your best imitation of drawing a perfect circle through those 4 points. But that's basically what the graph of that circle would look like. Now, let's say you wanted to graph this circle. Well, here you're subtracting 3, and here you're actually subtracting negative 2. Since it's a plus 2, it's like subtracting negative 2. So the radius, the center would be positive 3 for x and negative 2 for y. So that would be the center. And the radius would be square root of 40, which reduces to 2 square root of 10. And if you wanted an more accurate value, you could plug it in your calculator. But let me go ahead and just show you that graph. The center is at 3, negative 2, so it's right here. And then you know the radius is square root of 40, so you could estimate what square root of 40 is and go that many numbers to the right, that many to the left, that many up, and that many down. And then you could draw the circle. but when you're finished it should look like this. So there you go. There's the graph of that circle. Okay, now finding the equation of a circle with a given radius and center is usually pretty easy because you can use this formula. So if I say find its radius is 4 and the center is -4, 5, then basically you're going to say x minus -4, so it's going to be x plus 4 quantity squared, and then y minus 5 quantity squared equals 4 squared. So, and then I just squared the 4 to get. So there's the standard form of the equation of circle. Now, if you want to find the equation of a circle that passes through 2 points, well, that one's a little bit different. So here we know the center is 2, -1. So let's take a quick look at the graph. Okay, so this is the center of the circle, 2, -1, and the circle goes through this point, which is -2, -3. So basically, if the circle goes through this point, then the radius would be the distance between those 2 points. So all you have to do is find the distance between those 2 points, and we can do that with the distance formula. I'm not going to go through the calculation, but just know that I just found the distance between these 2 points using the distance formula, and I got square root of 20. So now I have the circle, I have the radius, which is square root of 20. I can put it in my standard form. So it would be x minus 2 quantity squared. Y minus -1 would be y plus 1 quantity squared. And then if you square the square root of 20, you're going to get positive 20. And so that would be the equation of the circle. Now, one of the things that you might have to do with circles is a circle can be given to you in this what's called the general form. And the general form is a little bit trickier. Now here's the general form of a circle. Okay. Now the reason I know it's a circle is because x squared and y squared have the same coefficients, 2 and 2. So I can divide everything by 2. Okay, so let's divide everything in this equation by 2. That'll give me x squared, y squared, minus 10x, plus 4y, plus 25 equals 0. Now let's get rid of this 25. We're going to move this 25 to the other side right here. And the reason I'm going to do that is because I want to add something to these 2 terms. Notice I grouped these x's, x squared and the x term together. I want to add something to this term that will make it a perfect square. And remember how to complete the square? Half of this -10 is -5. -5 squared would be 25. So I'm going to add 25. And then if I do that there, I've got to add 25 over here. I'm also going to complete the square for the y values. Remember, half of 4 is 2. 2 squared is 4. So I've got to add 4 to both sides. Okay. Now, over here, it completes the square. This is now a perfect square trinomial. This is now a perfect square trinomial. So this can be written as x minus 5 quantity squared. This can be written as y plus 2 quantity squared. And then if I add these together, I just get 4. So now I have it in standard form. And the center is 5, -2. And the radius is 2. So that's how you would convert it from general form into standard form. We'll finish this up with just a quick note about circles centered at the origin. If a circle is centered at the origin, you're just going to have x squared plus y squared equal r squared, where r is some number. So if you had x squared plus y squared equal 49, that would just be a circle centered at the origin, and the radius would be the square root of 49, which is 7. And I've got a picture of this over here. X squared plus y squared equals 49. Notice the center is right here at the origin, and then if you were to count how far it goes out here, you'll have 7 units this way, 7 units this way, 7 units this way, and 7 units this way. And so that pretty much completes the section 1.5 that involved several applications of graphing and circles and symmetry and things of that nature. And so we'll move on to another topic in the next video.